Today we are going to discuss the polar and rectangular forms of a sinusoidal waveform. Complex numbers such as polar and rectangular form represent points in a 2D complex that are referenced to two axes, horizontal being the real and vertical the imaginary, where j is used as an imaginary number equal to the square root of -1. A sinusoidal waveform is used to display the voltage supplied to an AC circuit over a certain period of time as shown here, where the waveform has an amplitude of A and a period of t. A phasor is simply a complex number approach to represent this sinusoid waveform and apply it to AC circuit analysis, where y-axis is equal to the imaginary part and the x-axis is equal to the real part. Here we will look at the general equation of a sinusoidal waveform in an AC circuit. Voltage equals A sine omega t plus theta degrees, where A is equal to the amplitude of the wave, omega is the angular velocity of the wave, which is equal to 2 pi times frequency, or 2 pi divided by period, and theta is equal to the phase angle of the wave. The peak-to-peak voltage of this waveform is equal to 2 times the amplitude and 2 root 2 times the RMS voltage, which is equal to the equivalent DC voltage of the AC circuit. Now, using the sine wave equation, we will convert this into polar form, hence finding the RMS voltage value. The sine wave, A sine omega t plus theta degrees, would go to Z at an angle of theta degrees, which equals the voltage RMS, where Z is equal to A divided by the square root of 2, and the angle theta is the same. An example of this in action can be seen below here. Since we have obtained the polar form, we can convert this into rectangular form, which is x plus jy, where x equals z cos theta and y equals z sin theta. Continuing on from the example before, we will convert polar into rectangular form. Converting from rectangular form back to polar form is just as simple, where z will equal the square root of x squared plus y squared, and theta degrees will equal the inverse tan of y divided by x. Using the answer from the example before, we will convert back into polar form to check that we have the correct values. Here, indeed, it is true that we have the correct values. Rectangular form is easy for adding and subtracting, while polar is easy for multiplication and division.